can't pronounce the last name very well. We have the current generator station. All right, the background of it. I'm going to go over the description of the current system, the steady state, the step response, the FOPDT theory, and the model theory, and then final conclusion. The motor input, the MOT, is a manipulated variable. It's sent to the generator, and then it's output to the lighting and to the computer. The computer outputs a signal, whatever you're wanting to input into the system, and uses the JT101 power transmitter, and then sends it to the recording controller, which sends it back to the motor, and then into the generator and to the light bulbs, and then back to the computer where we can use LabVIEW to put it into Excel. Here's our steady state curve for the group. Each individual one, like my range here, and then Con's range, and then Lance's range. We kind of figured out that right here where this jump is where the light bulbs start to light, which I don't know if that makes much of a difference, but that's where we get this great big jump here in the output amps. They all seem linear when they're when you look at them individually, but not as a whole system. And here is this is in my range, the 1 to 2 amps, the steady state. And there's the average and uncertainty of that. And then in the step response for lenses, it jumps really high. Like at mine, at 50%, stayed really low. It didn't have much of a jump here. It only went up like 0.8, where his jumped over 2 and actually got outside of his range. Which that was done this morning after the new bearing was put in the motor, which I don't know if the bearing was causing the engine to drag down. And so with the old values, we didn't have time to redo the new values. So this is the new value for one of them. I didn't have time to do all of them this morning. So it might make a big difference. And then the step response of mine at 38%. And then here goes to the gain calculations. We went over this previously in the last slide. And then the dead time calculations and the time constant. And then we have in the gain, these values were actually put in wrong to Excel. These are actually times 10. They would be 0.4s. 0.4, 0.6. We didn't realize that till we got in here today. So. And then the dead times are all pretty close with each other. And the time constant shows a big difference here, and this is in the range where I guess where the biggest jump is on the steady state curve. And then in the FOPDT model, we used the 5 seconds in the beginning, which probably really wasn't enough time to reach steady state, but that's the only way I could get mine to reach the steady state without going way over, or to reach the curve there. And this is the one from 38 to 58% in my range. And here's where we put the 38 to 58 and against the FOPDT model. And you can see the experimental and the experimental output and the model output are pretty close. I mean, you can't see the model output because the other one is overlapping and has a lot more data points as well. In conclusion, we measured the 1 to 4 output amps. The SSOC displayed the relationship between the power and the output. And as I said, the low, mid, and upper ranges have individually a linear behavior, but collectively the system is not linear. And the FOPDT could be used to model the system without actually having to do as many experiments.